Assalamualaikum warahmatullahi wabarakatuh. We are from Group 2 who would like to present about simulations modeling on Chapter 13. With members, Atika Putri Dianti, student ID number 108, Andika Ade Setiawan, student ID number 092, and Reza Novita Sari, student ID number 054. My name is Atika Putri Dianti and I will start the discussion. The idea behind simulations is to imitate real-world situations with a mathematical model that doesn't affect operations. Using simulations, a manager should do several things as involved: define the problem, introduce the variables associated with the problem, construct a simulations model, set up possible courses of actions for testing, run the simulations experiments, consider the result, that possibly deciding to modify the model or change the data inputs, and decide what course of action to take. Just like coins, there are both several advantages and disadvantages of using simulations models. Simulations is a tool that has become widely accepted by managers for several reasons. It is relatively straightforward and flexible. It can be used to compare many different scenarios side by side. Besides, recent advances in software make some simulations models very easy to develop. It also can be used to analyze large and complex real-world situations that cannot be solved by conventional quantitative analysis models. For example, it may not be possible to build and solve a mathematical model of a city government system that incorporates important economics, social, environmental, and political factors. Simulations has been used successfully to model urban systems, hospitals, educational systems, national and state economies, and even world food systems. Simulations also allows what-if types of questions. Managers like to know in advance what options are attractive. With a computer, a manager can try out several policy decisions within a matter of minutes. Besides, simulations do not interfere with the real-world system. It may be too disruptive. For example, to experiment with new policies or ideas in a hospital, school, or manufacturing plant. With simulations, experiments are done with the model, not on the system itself. Besides, it allows us to study the interactive effect of individual components or variables to determine which ones are important. The other thing is time compression. It's impossible with simulations. The effect of ordering, advertising, or other policies over many months or years can be obtained by computer simulations in a short time. And last but not least, simulations allows for the inclusions of real-world complications that most quantitative analysis models cannot permit. For example, some queuing models require exponential or Poisson distributions. Some inventory and network models require normality, but simulations can use any probability distributions that the user defines. It doesn't require any particular distributions. Meanwhile, several disadvantages of simulations models are as follows. Good simulations models for complex situations can be truly expensive. It is often a long, complicated process to develop a model. A corporate planning model, for example, it may take months or even years to develop. Besides, simulations doesn't generate optimal solutions to problems as do other quantitative analysis techniques, such as economic order quantity, linear programming, or PERT. It is a trial and error approach that can be produce different solutions in repeated runs. The actor managers here also must generate all of the conditions and constraints for the solutions that they want to examine. The simulations model doesn't produce answer by itself. Besides, each simulations model is unique. Its solutions and inferences are not usually transferable to other problems. Simulations models are categorized into three. First, Monte Carlo, with submodels, consumer demand, inventory analysis, queuing problems, and maintenance policy. Second, operational gaming, and third, system simulation. Monte Carlo. When a system contains elements that exhibit chance in their behavior, the Monte Carlo method of simulations can be implied. The basic idea in Monte Carlo simulations is to generate values for the variables making up the models being studied. There are a lot of variables in real-world systems that are probabilistic in nature and that we might want to stimulate. A few examples of these variables are inventory demand on a daily or weekly basis, lead time for inventory orders to arrive, times between machine breakdowns, times between arrivals at a service facility, service time, times to complete project activities, and number of employees absent for work in each day. Some of these variables, such as the daily demand and the number of employees absent, are discrete and must be integer value. For example, the daily demand can be 0, 1, 2, 3, and so forth, but daily demand cannot be 4.7362 or any other non-integer value. Other variables, such as those related to time, are continuous and are not required to be integers, because time can be any value. When selecting a method to generate values for the random variables, this characteristic of the random variables should be considered.
The material will be continued by me, Andika Ade Setiawan. Talk about Monte Carlo. 5 steps. There are 5 steps. First step, set up probability distributions. Secondly, build cumulative probability distribution in itself. And next one, establish interval or of random numbers for each variable. Next, generate random numbers in itself. And the last one, simulate the trials. Three Hills Power Company, about the Monte Carlo example itself. Three Hills provides power to a large city. The company is concerned about generator failures because breakdowns cost about $75 per hour versus a $30 per hour salary for per person who work 24 hours a day, 7 days a week. 7 days a week for management wants to evaluate the service maintenance cost, simulated breakdown cost, and total cost. Let's use Monte Carlo simulation to analyze Three Hills system cost. This is actually the problem, right? Here's how to solve it. Use the step first until the third one. Determine probability, cumulative probability, and random number interval breakdowns. Here's you can see under our PowerPoint. Okay, here's you can see for the time between breakdowns per hours, half, 1, 1/2, 2, 2/2, and 3. And number of times observed, 5, 6 until 19, and the probability 0.05 until 0.19, and cumulative probability mostly 0.05 until 1.00, and the random number interval is 1 until 5, 6 until 11, 12 until 27, and until 82 until 00. Next steps is that Three Hills power generator repair times. As you can see, determine probability, cumulative probability, and random number interval repairs. First breakdown, after that you go to repairs. After that, here's the result after you repairs the step 1 until 3. Now let's continue to the step 4 and the last steps, and we'll be continue the next material by my partner. Thank you.
My name is Reza Novita Sari, and I will continue the presentation. The last step for the solution is to generate random numbers and simulate. For the solution, we get the hours of worker number is 34 and the total hours of breakdown is 44. So the cost analysis for a 3 horsepower generator, breakdown times, Monte Carlo, first service maintenance. Service maintenance equals to 34 hours worker service times $30 per hour. So the result is $1,020. And for simulate machine breakdown cost equals to 44 total hours of breakdown times $75 loss per hour of downtime. So the result is $3,300. And last but not least, total simulated maintenance cost of the current system equals to service cost plus breakdown cost. So the result is $4,320. Operational gaming simulation model. Operational gaming refers to simulation involving competing players, for example, military games and business games. System simulation model. System simulation is similar to business gaming because it allows users to test various managerial policies and decisions. It models the dynamics of large systems, for example, corporate operating system, urban government, and economic systems. Last but not least, verification and validation. Verification of simulation models involves determining that the computer model is internally consistent and follows the logic of conceptual model. Validation is the process of comparing a simulation model to a real system to ensure accuracy.